Alright, decent people, this is going to be a quick tutorial on setting up your ILS assistant, which is the Sidara and Startara system. Okay, how do we do this? So basically what you need to do, you will see a template. I have already done one myself, of course, but I am going to, for the purpose of the video, delete that for you right now. So let's delete. Oopsie, actually I don't want to delete that. There's a reason I don't want to delete that. Let's delete the localized antenna there. So you start off with oh, this is actually my easy airport. So if you have the template already, you would basically find this template like this BXL like this. You can delete, of course, if you don't need the extra one. If you don't have a second airport, you can delete BXL, whatever, and you can delete again the BXL. So let me just explain what this is. So the data, this is just important for the system to know that there's ILS or navigation data for the specific airport. So I has just a short, for my airport is the Andrew Holderness Airport. So I has the short name for that, or the current name for it, code for it. You do that, do your runway number, which is 14, or whatever direction is. To find the number for your runway, it's whatever the heading is to the runway is. So from the city, we're flying 315 in, so our runway would be numbered 32, which is basically 320, so heading 320 inwards. Okay, that's all. This is all runways real world are usually numbered to the true heading by the 10th degree. So that's 40 to 32L, and my BXL, okay, of course, what I would first have to do, let me delete the localized antenna there, is I first get this brick. Okay, I get this brick, find where I want to get the plane to land. So where do I want my plane landing? Now you always want your plane to land in the touchdown zone, so find whatever touchdown zone, if you have a properly designed touchdown zone, find where it is and put this glide scope thing in the middle of that. Okay, so where the center line is, of course. So I put it here. I am going to use the center line to guide me here. You can make this, whilst you're editing, you can make this seeable, just so you know what you're doing. Put it there, so now it's in the center line for sure. This is important for the localizer as well, very important for the localizer. Okay, so put this here. Now I know that I need to find out where this runway is facing by finding out where the front face is. So clearly my runway is going this direction, but my front face is pointing that direction. So that's clearly not where my runway is facing. Put 45 degrees here, because of course 45 will give you a 360 turn eventually, and turn it until your front is facing the direction the runway is going in. Okay, and because you're coming in from here, of course you don't want your front facing that way. You want it facing the direction your plane's going to fly into. So we know here then, well, our orientation is 45 degrees from true north. True north is facing 0. Because Roblox's orientation is orientated incorrectly, truly your true heading is 3115 again here. It's actually parallel to my runway over there. So this is 3115, but Roblox says it's 45 because they're orientated wrong. So Roblox has east and west in the opposite way, but you don't really need to care too much about that, because we've done all those fixes in the system itself. So you just need to know what your orientation here is. So this is 45. What I am going to do, which is already done for me, is just put 45 in there, whatever my angle is goes in there. and I've lifted this up just a bit, and that's what I'm going to do there. Now once I've found out what my angle is, all I really need to do is set this back to 0 so that it stays facing true north, so that the plane does fly 45 degrees, because if you leave this at 45 degrees, the plane will fly that way, because it's flying 45 degrees to wherever the front is facing. Okay, so that's simple. Now just duplicate this, and we're going to make this our localizer. Antenna. So we're just going to copy paste the name from here, that's why not. We're going to make this our localizer antenna, and we just need to make it, of course, facing true north, just so that we can move it all the way to the end of the runway. Your localizer is always found at the end of the runway because it makes sense that the plane shouldn't really, the moment the plane passes it, it will be flying the reciprocal direction from that waypoint. So if you when you're flying towards this, you're flying 45 degrees towards this antenna, okay? But the moment you fly past that, you're flying on the opposite side now. So you would be flying, if you're flying 115 in, you'd be flying 135 out on the 135 radial, okay? And if we're using roadblocks heading, if you're flying 45 degrees in, the moment you go past the center of this, you will be flying on the 225 radial. But if this is too confusing for you, of course just ignore that part. Just all you need to know is move your localizer to the end of the runway, and then do the same thing again. Set your orientation to 0. With that both done, all you need to do is make them both transparent, and that's stage 1 done. Now stage 2, of course, once you've done your BXL and you've done your runway, just make sure, of course, that you've set the same runway number there again, and then all you need to do is, in your BXL, it will be blank like this. Just take this, find your BXL, and set your runway data there. Okay, so set here your true radial. I've already done it for myself. That's 45 degrees, which is the roadblocks radial, and my true radial is actually 315. So this is the number you will see when you're flying on the plane, what heading you're flying in, okay, roughly. So that's done then, that's one part of it. Now the more difficult parts, but, well, I wouldn't say difficult, but the part that will interest you more, of course, is the glide scope waypoints, okay? So how do we do the glide scope waypoints? Let's make that, it's supposed to be facing there, of course, almost forgot. So how do we do the glide scope waypoint? Well, assuming that, of course, you will find that your glide scope brake and stuff will not be close to your runway, so you use the same method I used for the localizer. Duplicate this, okay, name it your glide scope waypoint, remove whatever is inside of here, copy and paste inside of here. Of course, set your radial you want the plane to fly to. In this case, of course, it's definitely 45 degrees, like that. Set this, of course, to the set your glide scope waypoint now, of course, to 45, because you're going to be moving it. Once you've done that, move this here, duplicate your glide scope antenna, move that here, make a model, alright, and then get your calculator. So this part is important for you to figure out the distance and the distance data that you need to fill in the remaining stuff here. Great, so let's get moving, okay? So a normal runway will have its entrance waypoint about 4 nautical miles out from the runway, okay? So we need to basically find out where 4 nautical miles is, and I've done a calculator that does all the calculations for you guys, because I can't trust you guys to copy and paste sometimes, or do stuff like the maths. So done the calculator for you. Of course, when you find this, it will be disabled. So just get your calculator, undisable it by going to properties and undisable, and then move it to your model. Okay. So just press play to make sure our calculator is working. As you can see right here at the moment, we have 0 start, 0 feet, and 0 nautical miles right there. Now, you've seen a GS of 3.8. That's just because I filled this in earlier on. I'm just going to quickly remove all of that. Right now, I'm going to set them all to 0. There we go. Okay, so if I press play now, that everything will be like 0. You see everything 0. Or nan, I, and D, and which just means you can calculate anything. So that's perfect. Now let's get moving. Take your glide scope waypoint and start moving this, okay? We want to try and get 4 nautical miles. So let's just keep moving. Keep moving. When you feel like you want to just check how far you've gone, press play, and we can see we're only about 1.5 nautical miles out. So that's very small. It's nothing really. Not enough distance. I can see the runway from here. That's not enough distance for you to properly align. My ahead is about 4.5 out, so that's enough time from the city to in. So we keep on going as far as we can till we get to 4 nautical miles. And we're really near the beach now, so I think this might be 4 nautical miles from this airport. 3 and that was, wait, was that 3 nautical miles? That's 3 nautical miles there. Yep, that is 3 nautical miles. We will pull her to near the end of the beach. And we're at 4 nautical miles, so I have 4 nautical miles here. Of course, you can put any distance you want, just know that, of course, the closer it is and the higher it is, of course, the more steeper your glide scope is. Your plane might not even be able to do it if it's not got that, the type of kit that London City planes do. So now that I know I'm at 4115, where are we? Nautical miles. Actually, now we need to go and fill in the data. So we're going to take our data, go and fill in. This is our start. It's going to go here. Make sure you remove any space. If there's any space here, make sure you remove it. Fill in our feet here. And fill in our nautical miles, okay? Here with nautical miles, I generally just want to leave it with that type of thing. I don't really want to go into 4 decimal places. So 419 is our nautical miles there. Okay, so what's our height? Well, let's see what our height is now. To do the height, just choose whatever altitude you basically want. I would lift this to maybe a good height for me is probably that I would go a good height for this. I generally would say a good height for my airports. I don't want a plane below 1,000 feet when it's reaching a waypoint. So I'd put my height to let's see, maybe like 1,000, 7,000, something around here. And that's the good height for me. I'd go 1,000, 7,000, whatever you want. You can put the altitude whatever you want, but this is 1,000, 7,000 for me. And what would that? So I now go and fill in that studs is 1,007. But we need to find out what it is in feet. So all we need to do is take that altitude and times it by 0.9 2. Okay, go and use your calculator. This should be like about 1,500 or something. Yeah, 1,064 for me on the dot. So my height in feet is 1,064. Now that that's filled in, we'll be able to know what our glide scope is. So what is our glide scope? It's like maybe 3.5. So our glide scope here, again, we're going to use 2 decimal places for it. Our glide scope here is 3.1. Because we do want an accurate glide scope, we will take 4 decimal places. 4 decimal places here. That's the only exception we ever do stuff like that. You can take the whole number if you feel like it. Generally, I just take the 4 digits. So that technically would be a 4. We would see that as a 4-degree glide scope real well, because the glide scopes are only really generally looked at by the what you want to call the ones. So there's no in between. It's like if you're 3.5, you're going to be 4. If you're higher than 5, and if you're below 3.5, you're going to be 3 degrees, etc., etc. So this is a 4-degree glide scope pin. Once that's calculated, just disable your calculator, remove your calculator from the ILS folder, so that when you close this, you have your calculator there. Okay. Delete your glide scope antenna from here. Make sure your waypoint is pointing to true north, which is 0 orientation. It has to be. The front needs to be facing that direction. Okay. Make sure all of your stuff are facing an orientation of 0. Okay. With that done, the waypoint here is 45. So yeah, I'm a happy bunny. That is done. Remove the model there, so let's slice up, and pretty much done. There's nothing else you need to do. You've done all the calculations. Make sure your BXL is connected to, and you're pretty much done. Any questions, any issues you have with this, let me know and I will be happy to help. See ya.